Okay, this is gonna be a raw recording of distance of the nearest cell having 1. So we are given n into a matrix, right? And we have to find the nearest 1 distance for each of the nodes. So what we do is in this problem, right? We have the grid matrix, right? On top of that, we need to initialize a visit matrix of the same size and the distance as well. So distance matrix is going to be the answer. So first we figure out the size of the grid size, right? And then we are doing a BFS on, so we need to initialize a queue, right, of row, column and steps. So steps is going to be the distance which we are going to calculate, right? So first phase of this algorithm involves in pushing all the ones in the grid matrix into the queue, because we are gonna do a BFS on each of the one in the grid, right? So and we are gonna set the visited of these ones to 1. So we are gonna have in the queue, we are gonna have all the ones, right? Ones coordinate. So while the queue, now we're gonna, the second phase is gonna be the BFS, where while the queue is not empty, we are gonna pop out each of them, and we are gonna suppose like this is gonna be the first node we're gonna BFS, right? So what you're gonna do is we're gonna pop out this, and we're gonna change the distance of this, right? Distance in the distance matrix to steps, which is going to be 0, because this is the first element, and we already did the steps is equal to 0, and we already pushed the steps is equal to 0 here, so it's going to be 0. So now we are going to we're going to check his neighbors, right, using the delta row and delta column, which will initialize. So if it's a valid, if the neighbors are valid, and if it's not, if their neighbors are not visited yet, we visit them in the matrix, we turn them into 1, and we push the nodes plus 1 steps plus 1 into the queue itself. So this goes on until the queue is empty, right? So when we get to this node, right, when we get to this node in the queue, right, we pop out this, and we set the distance to whatever this queue was holding. So that is going to be the whole algorithm, and we are going to return the distance matrix. So that is as simple as that. Just the algorithm, the solution sounds very easy, but getting this is very complex because of this formula, which we did not use, right? We did not use this formula, whereas we used some other way of calculating the distance, by using a third pair which includes the steps, right? So that's how we calculate the distance, which so this can be a little complicating, right? Okay, we did